Hello guys, welcome back. In this video we'll be looking at equal matrices, and as the term equal suggests, synonym for that would be same. So for two matrices to be considered equal, they must satisfy two criteria. The first one, the order of the matrix must be the same, and the corresponding element must also be the same. All right, so the first criteria was the order of the matrix must be the same. What do we mean by the order of the matrix? The order of the matrix tells us how much rows and columns are in the matrix given. So for example, we're given A. We count our rows, and remember, rows run from east to west. 1 row, 2 rows. And our column, 1 column, 2 columns. So we can establish that A is a 2 by 2 matrix. And let us look at B. 4, let us look at the rows. 1, 2, and the columns 1, 2. So B is a 2 by 2 matrix as well. So both matrices satisfy the first criteria, where the order of the matrix is the same. All right, let us look to see if these matrices satisfy the second criteria, where the corresponding element in both matrices must be the same. So our first element in the first row is 4 in matrix A, and our first element in the first row in B is also 4. So we know that 4 is also equal to 4. All right, but everything in the matrix, every element in the matrix, every pair must be the same. So we are going to be looking at this -3, which is the second element in the first row. All right, so the -3, which is the second element in the first row, and we're looking at in B, the second element in the first row as well. So in both cases, we see a -3, so that is equal. -3 is equal to -3. All right, let us look at the first element in the second row. We see a -2 in A, and in B, the first element in the second row is also -2. So let us look at our final element. So that's the second element in the second row. In A, we have a 1, and the second element in the second row in B, we have a -1. Is 1 equal to -1? No, they are not the same, because this is a +1 and this is negative. So the signs are different. So therefore, A and B are not equal matrices, because it did not satisfy the second criteria. Let us look at another example. All right, so in example 2, we are given that C is equal to that, D is equal to that, and we want to find out if they are equal matrices. Right, so first thing we need to establish is if the order of the matrix are the same. So for C, let us examine how much rows. 1, 2. Mommy, what that? And how much column? Mommy, what that? 3 columns. Mommy, 1, 2, 3. What? Nothing. Alright, so C is a 2 by 3 matrix. And let us do the same for D. 1, 2, 3. 3 rows. And how much column? 1, 2. So D is a 3 by 2 matrix. Let me ask you now. Are they the same? No, they are not the same. So therefore, they cannot. We don't need to establish the second criteria because the order of the matrix is not the same. So therefore, it's not an equal matrix. Let us give it a shot at one more example. All right, so we are looking at example 3 and we're given that A is equal to and B is equal to, and we're asked to determine if they are equal matrices or not. So remember, it must satisfy 2 criteria. The order of the matrix must be the same. So let us write down the order of each matrix. And this is we have 1 row, 2 rows, and 1 column, 2 columns. So this is A is equal to a 2 by 2. And let us look at B. We have 1 row, 2 rows, and 1 column, 2 column. So this is a 2 by 2. So they are the same. Let us look at the second criteria, which to see if it satisfies the second criteria, where the corresponding elements must be the same. Corresponding or matching, elements in the matching position. So for first element, first row, 4. In B, first element in the first row is also 4. So that's the first element, they are equal. So the second element in the first row and the second element in the second row in B, 7, 7, they are equal as well. 8, the first element in the second row is 8 from A, and the first element in the second row from B is also 8. So 8 is equal to 8. And then for the second element in the second row in A, that's 2. And the second element in the second row in B, that's 2. So we realize that they are all the same. The corresponding elements, they are the same. So it satisfies the first criteria and it satisfies the second criteria, which means A and B are a pair of equal matrices. Thanks for watching. Hope you learned a lot today. See you in my next video. Bye. Love y'all.